right, hello Trig students. How are we today? This is your video for our section or chapter 5 section 1 notes. We're going to begin chapter 5 by introducing you to some really important identities that we are going to use throughout chapter 5. And so going to be important that as you go through this video, you take some good notes, you try to understand everything as best you can. I would recommend that as you go through the video, you pause it as you need to so you can keep up in terms of writing. I would highly recommend you put the examples down that we go through in these notes as well. All right, so the first thing we're going to do is introduce you to our fundamental identities, and they are really going to be the building blocks of, again, a lot of what we do here in chapter 5. All right, so let's begin with our 8 fundamental identities. We have 8 identities that are grouped into 3 different groupings, okay? So the first identities that we want to talk about are identities that we are already familiar with. We've talked about these before, but they are those reciprocal identities, all right? So we know that cosecant is equal to 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent, right? They're reciprocals of each other. And so we know those identities as the reciprocal identities, again, because they're all based on reciprocals. All right. Now, one thing that we should remind you of is that these identities also work in the opposite direction. So not only could I say that cosecant is equal to 1 over sine, but I could also say that sine of theta is equal to 1 over the cosecant of theta. All right. So that would be kind of an alternative way to think of that reciprocal identity. So really we could do that with all 3 of our reciprocal identities, and in a way we could almost think of our reciprocal identities as having 6 different identities. All right, so that's our first set of identities, and again I would encourage you to pause the video if you haven't already and write those down. All right, the next set of identities that we want to talk about today are what we call the ratio identities. All right. Now, if we think about our unit circle, in a way, we've actually already worked with these identities, right? Back in chapter 4, we defined these identities on the unit circle, and we thought of tangent as simply being sine over cosine, or excuse me, tangent as being y over x, right? And if we think about our unit circle, right, we said, well, hey, y is the sine function, x is the cosine function. So really this is an extension of what we learned in chapter 4 based on the unit circle, all right? So again, that's our ratio identity, and we have one for cotangent as well since it's reciprocal, all right? We could, obviously flip that over and make a cotangent function, all right? So those are our ratio identities, okay? Now, the next type of identity that we want to focus on is a grouping or a set of identities that we call the Pythagorean identities, okay? Now, just by the name alone, and also even looking at the form of them, you can probably guess that these identities have something to do with the Pythagorean theorem, and you would be correct in that assessment, all right? And so if we again go back to our unit circle, all right? So here would be an example of a unit circle, right? We have a hypotenuse of 1, right? We think about a movement on our point that we label x and y, right? So if we set that relationship up in the Pythagorean theorem, right, we end up with this identity of saying, well, hey, this would just simply be in the Pythagorean theorem, x squared plus y squared equals 1 squared, okay? So again, if we apply what we know about the unit circle, well, we refer to cosine as x, right? So that's our Pythagorean identity. Cosine squared plus sine squared, or as I have it written on here, sine squared plus cosine, doesn't matter, equals 1, okay? And I like to refer to this identity as the great mathematical pickup line. So for some of you guys who are hoping to score a date anytime soon, you could walk up to a young lady who may strike your fancy and say, hey, I wish I was sine squared and you were cosine squared because together we'd be 1. All right, cheesy Coach H math joke of the day for you. But hopefully that helps you remember that Pythagorean identity because we're going to use that a lot, right? Now, all the other Pythagorean identities are based off of that first one, all right? And so just to kind of illustrate how we came up with 1 plus cotangent squared equals cosecant squared, and the third identity, tangent squared theta plus 1 equals secant squared theta, is they are all based on that first Pythagorean identity, okay? So as you can see here, as we take those Pythagorean identities, if I start with sine squared plus cosine squared equals 1, and I divide the entire function by cosine squared, right? Well, we know sine squared over cosine squared. Well, we know sine over cosine is tangent from our ratio identity, so that makes this tangent squared. Cosine squared over cosine squared is 1. 1 over cosine squared, well, that's our reciprocal identity. So we know 1 over cosine is secant, and that's how we can create an entirely new Pythagorean identity. But again, it is based off of the same statement, x squared plus y squared equals 1. It's just been manipulated a little bit. And the same thing with our middle Pythagorean identity. If we take sine squared theta plus cosine squared theta equal to 1, we divide the entire thing by sine squared. Well, sine squared over sine squared is 1. Cosine squared over sine squared is cotangent squared, and 1 over sine squared is cosecant squared theta. All right? So these are really important identities that we are going to use here throughout Chapter 5. And so again, if you have not paused the video and written all 8 of these identities down, I would highly recommend that you do that. You don't need to worry about the unit circle in this example down here. That's just illustrating where those came from. All right? Now, one thing I will point out as well is that all of these identities can be manipulated, kind of like we did with our reciprocal identity over here. I could take any of these Pythagorean identities and I could create a whole new identity. So for example, let's say I just subtracted cosine squared to the other side. I could create an identity that says sine squared theta equals 1 minus the cosine squared of theta. And that's a manipulation of that base identity, sine squared plus cosine squared theta equals 1. So it is important that we kind of recognize all of these identities can be manipulated around, and you'll see how we use those even in our examples today. All right? So let's continue on here, and let's take a look at a couple of examples. All right? So the first thing that we're going to do with our identities today is we are going to use them to simplify. All right. Now, this is really a precursor of the work that we are going to do tomorrow. And so I will warn you, these problems, the first time you do these types of problems, they can be a little bit tricky. You kind of have to be a little creative in your thought. But I would just encourage you to try every problem. And if you get stuck, don't spend more than a minute or two on it and move on to the next problem. And sometimes as you work another problem, you can come back to these and then you come up with some new ideas or some new ways to simplify them. All right, so please don't let frustration cause you to focus too long on one problem. Feel free to move on and work your way through. All right, now as we complete these problems, and we're going to do the same thing tomorrow with our next step, is I'm going to ask you to always show your work, all of your work. All right, a key part here in Chapter 5 is really not going to be what's the answer, but how did you get to the answer? And so I need to be able to see your work. And I'm also going to ask you to put an explanation off to the side. All right. Some of you might have some flashbacks to geometry with proofs, like a 2-column proof where you have your work on one side and your justification for why you could do that work on the other. And in a way, that's kind of what we're going to do. All right. So let's go ahead and take a look at this problem. All right. So if we want to simplify sine of x times cosine squared of x minus sine of x, the first thing I want to do is I just want to analyze the equation. Okay, my goal is to simplify this. I just kind of want to look at some things. And I might notice here that, hey, this term, which is all one term, right, has a sine of x in it. And this term also has a sine of x in it. Right? So a lot of times in algebra, if I thought of this as an algebraic equation, if I saw something like that, my thought would be to factor that out. Well, that's exactly what we can do in this problem. So we're going to go ahead and factor out a sine of x, all right? And that's what our next step is going to look like here in blue, okay? So we go, okay, we've got sine of x is equal to cosine squared x minus 1. Now, I hope when you look at that, what's left in parentheses, you look at that and say, hey, this kind of looks like a Pythagorean identity, right? This whole cosine squared x minus 1, right? Well, if you look back on our previous slide, we kind of manipulated our sine squared plus cosine squared equals 1, and we moved the cosine squared to the other side, and that gave us an identity that said, hey, sine squared x is equal to 1 minus cosine squared of x. Now, that's not exactly what we have in this problem, but again, just illustrating how we can use these identities, right? So if I take a look at this and say, hey, okay, I know that 1 minus cosine squared of x is equal to sine squared x. Well, this is the opposite of that, right? Like all the algebraic signs are opposite. So the cosine down here is positive and the 1 is negative. That's the opposite of what I have up here, right? Well, that just means then, hey, switch all of these signs, and cosine squared x minus 1 must be equal to a negative sine squared of x, right? Again, just using algebraic skills. So we're in the process of simplifying this down, right? Utilizing some algebra skills and our identities, right? So my explanation here, we just substituted in the Pythagorean identity. All right, and so now again, we can keep substituting. Well, I can go ahead and multiply these together. Well, trig functions are a lot like just a variable. If I had x times x squared, right, that would come out to be x to the third. Well, here we're multiplying sine times sine squared. It's negative, right? We're going to end up with a negative sine to the third of x. And that's really as far as we can go. We've kind of really simplified that problem down from multiple trig functions, sine and cosine, and a subtraction problem. We have now shown that, hey, this equals a negative sine cubed of x, okay? So this is kind of the type of work that you're going to be doing with some of these identities today, is utilizing them to just simplify a problem down. So let's go ahead and work through a couple more examples here of this. Just so you can see some more work with these identities, okay? And if you want to pause the video again at any time, I would encourage you to do that, maybe in between steps on the problem, or you can watch all the way through and then jot down some notes when I get done with each example problem, all right? So here's our next example problem. We're going to take the sine of t, all right? T is just theta, it's a variable, right? It's representing our angle in this problem, plus the cotangent of t times the cosine of t, okay? And again, we want to simplify things down, right? That's our goal here. So this problem is a little bit different. Again, anytime we work one of these problems, we kind of want to start to just analyze it a little bit. So I look and I go, hey, I got sine of t, I got a cosine, I got cotangent. There's nothing here that I can factor out like I could in the last problem. So I might have to approach this a little bit different, right? But something that you're going to see is really helpful on these types of problems is if you get stuck, try to change everything to sine and cosine. All right, sine and cosine are really versatile identities. If you look back on your notes about the 8 fundamental identities, almost all of those identities involve sine or cosine in some way, right? 6 of the 8 identities have sine or cosine in them. And so they're a really versatile piece. There's some pretty important players when we're simplifying. And so recognizing that, I might look at this cotangent and say, hey, I'm going to turn that into cosine over sine using a ratio identity. All right, so let's go ahead and make that substitution. All right, so now our identity's changed a little bit, the work that we're doing here. So now we have sine t plus, here's that ratio identity, cosine of t divided by sine of t. And so again, we substituted the ratio identity. All right, well, now that once we did that, it'd be kind of nice to simplify this down. So let's go ahead and multiply these together. So I have cosine over sine times, think of this as cosine over 1. All right, and so if we do that, we're now going to have sine of t plus cosine squared t over sine t. All right, again, we're multiplying and trying to simplify things down, okay? So then we think, okay, what's our next step? What should we do next here? Well, if we want to simplify this, it'd kind of be nice to get rid of this addition sign. And so maybe I could add these two together. Well, I need to have common denominators to do that. Okay. Now you might be thinking, okay, why in the heck would we add those together? Well, just think about this for a moment. If this is over sine, right, and I get that as a common denominator, I'm going to end up with sine squared on top over here over sine. And I kind of like where that's heading in terms of an identity, right? So we always want to think about how can we use our identities, kind of look ahead a little bit in the problem. All right, so let's go ahead and get common denominators in this problem. So we're multiplying the sine of t, right? I mean, if we just kind of put some work over here, right? We basically multiply this by sine of t over sine of t, right? And that's where this sine squared t minus sine of t came from, okay? We didn't do anything to this fraction, right? It already has the common denominator of sine of t, so we don't have to worry about anything there, all right? Well, now that we have common denominators, let's go ahead and add those together, all right? So if I add those together, right, when we're adding fractions with common denominators, we just add the numerators together. So now I have sine squared t plus cosine squared t in the numerator all over sine of t. Well, again, I like seeing that identity right there. That, again, is one of our Pythagorean identities. So let's go ahead and substitute that. So that leaves me 1 over sine of t. Well, I can still simplify this a little bit further, right? Because using my reciprocal identities, I know that 1 over sine of t is the cosecant of t. So we took this entire statement that we began with, and all of this simplified down to just simply cosecant of t. All right? So again, another example of how we just utilize algebra. Things like common denominators and multiplying and adding fractions, right? All of those are algebraic skills. And then we're also including our identities to help us do some manipulation as well through some substitution, okay? So let's do another example of these. This one's a little bit different, okay? So in this one, we've got two fractions, right, that are being added together. So again, you just kind of take that first thought, well, it might be smart for us here, just like the last problem, to get common denominators. Now, common denominators here are going to be a little bit different, right? My common denominator as a whole is simply going to be 1 plus cosine of x times the sine of x, right? So this fraction, I need to multiply top and bottom by sine of x. This fraction, I need to multiply top and bottom by 1 plus cosine x. So let's go ahead and do that, all right? So that's what this is going to look like, just kind of showing that work. And then I'll go, hey, let's go ahead and multiply these numerators together, okay? And so when I multiply those numerators, when I start with my first fraction in the problem, right, sine times sine is sine squared, okay? And then I'm going to go ahead and multiply that cosine through, so I get cosine x times 1 is cosine x. Cosine x times cosine x is cosine squared, so I'm going to go ahead and add those together, right? Then again, hopefully you're putting some pieces together here. You say, hey, I like seeing this sine squared x and this cosine squared x, right? There is addition. We can kind of rearrange these pieces as we wanted, right? But we know that sine squared x plus cosine squared x is 1, all right? And so we go ahead and make that substitution, right? We're still left with that cosine of x that we had hanging out here in the middle. So now we have 1 plus cosine of x. We haven't done anything with the denominator. But now we kind of like what we see in the numerator and the denominator, right? We've got common factors here. These things could cancel each other out, right? Which is just going to simply leave me with 1 over sine of x. And I know, again, that 1 over sine of x, using my reciprocal identities, is cosecant. That should be an x there, just simple typo, all right? But that should leave us with the cosine of x, all right? And again, we simplified that problem down quite a ways, okay? So this is one type of problem that you're going to see on your homework assignment today, is these simplifying problems, okay? Again, utilizing algebra and our fundamental identities. So a couple more types of problems that are going to utilize our identities today. One skill that we want to start to set up today is our ability to factor a trig expression. And this is going to be really helpful over the next couple of days, okay? So this problem kind of starts like simplifying. But if we take a look, we have different trig functions, right? But hopefully we look at that cosecant squared of x, right? Anytime we see a squared trig function, something that might first pop to our minds is, hey, Pythagorean identity, right? So if you take a look at your Pythagorean identities, we know that one of those identities told us that, hey, the cosecant of x is equal to 1 plus the cotangent of x, right? That's an identity. These are equal to each other, okay? So I'm going to go ahead and make that substitution of that Pythagorean identity. And now I want to simplify things down, all right? This 1 and this -3 can be combined, all right? I can't add the cotangent square. I can't subtract the cotangent squared and the cotangent, so those are going to be left alone. All right, so at this point, I now have cotangent squared of x minus cotangent of x minus 2, okay? Now, here is how I want you to start to see a problem like this. All right, this problem is very similar to just a quadratic statement. All right, so think of this as x squared minus x minus 2. Okay, if I wrote it that way instead of with a trig function, most of you go, oh, I could factor that, right? And this would factor into just simply x minus 2 and x plus 1, okay? Now we have that exact same thing going on with this trig function, right? Except instead of x, we have cotangent of x, all right? But the thought process and the mindset is still the same, all right? I can factor that. So that's our next step in the problem, all right? Is we want to even look for quadratic trig statements. So this factors into, again, not x minus 2, x plus 1, but would factor into x or cotangent of x minus 2 and cotangent of x plus 1, right? So we're going to factor it just like we would a trinomial. Now, that's as simple as we can go in a problem, but again, this is going to be a skill that is going to help us throughout Chapter 5, is this ability to recognize when we have some trig functions that function like a trinomial, all right? And that's as far as we can go. That's factored, and we'll do more with this later on here in Chapter 5, all right? So one more type of problem I want to take a look at today, and then we'll be all done with today's notes, all right? So the last type of problem that I want to look at today is what we call trig substitution, okay? And so this problem is pretty simple. You know, if we just read the directions, we're going to do what it says, and then we're going to simplify down, okay? So it says, use the substitution of x equals 2 tangent theta to write the square root of x plus, or 4 plus x squared as a trig function of theta, all right? Now, what we want to recognize here is they're telling us exactly what to use. So we're going to take this, and we're going to substitute it in for x, okay? That's the work. And then we're going to simplify, okay? So if we go ahead and substitute that in, now, we need to recognize, right, that it's 2 tangent of theta is going in for x. Well, x was squared. So that means all of this statement needs to be squared, all right? So that's our next step. So if we take 2 tangent theta times 2 tangent theta, we would end up with 4 tangent squared theta, all right? So again, we're simplifying here, just using basic algebra. All right, now I take a look at this and go, well, hey, I got two statements here, right? I have the term of 4 and the term of 4 minus tangent squared theta. Well, if you go back to our first simplifying example, we factored a 4 out of we factored the common term out. So in this case, we're going to factor out the 4, right? That leaves us 1 plus tangent squared theta, right? Well, again, hopefully you looked at that and went, hey, that kind of looks like some type of Pythagorean identity. That might be equal to something, and you would be correct, right? We know that 1 plus tangent squared theta, if you look back at your Pythagorean identities, is secant squared of theta, right? Well, now, if we go back to this original problem, we couldn't take the square root of this because this addition sign was in the way. Well, by using a trig substitution, we have actually eliminated the addition problem. And now I can actually take the square root of this, right? The square root of 4 is 2, and the square root of secant squared is secant. So we have just taken the square root, and simplified this all the way down to 2 secant theta, right? So we use the substitution to change this statement, the square root of 4 plus x squared, into a function of theta. All right? So that brings us to the end of our lesson today. So here's your homework assignment. Now, if you need to go back and watch any part of this video, I would highly recommend that you do that. Hopefully you took some notes and jotted some things down. And again, just practice is going to help a ton as you work your way through these identities. All right? So thank you guys for watching. Get to work on that homework assignment, and have a great rest of your day.